Assalamu alaikum everyone. Hope you all are doing very well and already have started your revision for the tomorrow's test, that is from 10.1 to 10.3. Am I audible to all of you? Uh, you can tell me in the form of comments. Am I audible to all of you? Okay, fine. So 10.1, we already have discussed it in the class, and at last, if we have just some sort of time remaining for that session, we will have a look for 10.1 question answers and its revision part. But quickly, we are just moving towards our next topic, that is 10.2 from your books, and it is action and reaction pairs. You all must have to open your books. You must have to write down different questions that we will discuss in the class and what will be the specific answers for them. Got it? So we are just going to start our topic, that is 10.2. 10.2 is it's about action and reaction pairs. So the question that can be made from that topic is, two forces always occur in pairs, and what is the relationship between the two forces in pair? So you must think of something when a hammer hits a nail. So you think about the hammer hitting the nail, but what about the nail? Does it do anything back to the hammer? Are you able to think about that? So one of the most elegant idea in all of our science, that is Newton's third law. And what is this third law? That every action has a reaction, every forces come with a partner, you can say. And when you hit a nail with a hammer, you think only about the hammer hitting the nail, but simultaneously the nail pushes back on the hammer with an equal force in the opposite direction as well. And these are action and reaction pairs, which are equal in size, opposite in direction, and critically, you can say acting on different objects. Like this law is always true. Every force in the universe has an equal and opposite force, or the partner, you can say. So, if I'm just going to explain that what you must have to write, or what will you have to think about, or the key points. So you must have to write like forces always occur in action reaction pairs, and this is Newton's third law of motion. When objects, let's suppose we are taking an example of object A and B. We are just assuming different two objects. So when object A exert a force on object B, now this is the action. So as a reaction, what will happen? Object B always exerts an equal and opposite force back on object A. This is the reaction. So the two forces are equal in magnitude. Magnitude means they are equal in size, or of having same size. They are opposite in direction, like one pushes or pulls one way while the other pushes or pulls the other way. So acting on different objects, never on the same object. Acting on different object, like hammer hits the nail and nail hits the hammer back. So here two different objects are involving in this action and reaction pair. So hopefully you got this thing. You also have a diagram that is given on your books page, and there are some sort of arrows which are equal in size but opposite in direction and are from different objects. They are just evolving from the different objects. Fine. So what you just must have to be remember for this answer, it's the Newton's third law of motion, and it is the action and reaction pair forces, in which action and reaction are equal in size or magnitude but always opposite in direction. Hopefully you are very much clear for this question. So moving towards our next question, you people can easily see a book on the table on your books, the diagram given over there. So the question that can be made from this thing, a book rests on a table. Identify the action force and the reaction force and state which object each force acts on. So now you just have to think about some things like the book pushes down on the table. So, does the table do anything in the back? What might it do? So, there are always two action reaction pair in this situation. So, pair one, I have already told you when we were just giving the lecture of this topic. There are two different pair of action and reaction forces. So, for the first pair, the book pushes down on the table bete. This is a contact force. Fine, because now the book and the table are in contact with each other, and now book is pushing down on the table. So as a result of its reaction force, the table pushes up on the book with equal force, which is called your normal force or the reaction force, which is pushing upward on the book. The second pair of forces, action and reaction, is over there. One of them is gravity, which is a non-contact force. So the Earth's gravity pulls the book downward, which is also known as its weight. And what will be its reaction? The book pulls the Earth upward with equal gravitational force. Both these pair obey Newton's third law of motion, that is, they are equal, opposite, on different objects. You can also have a look on your diagram as well, and you can draw the arrows over there. So the first arrow in the first pair, like when the book is pushing on the table and the table pushes back on the book, so the arrow, firstly the arrow will be drawn downward from the book towards the table, and the second arrow as a reaction force will draw from the table towards the book. Got it? And in the next thing, what from where they have to just draw the arrow over there, they separate the earth book gravity, which is a mutual attraction between earth and the book. So here that thing is also, these arrows will also be drawn over there. Got it? So which things you must have to be keep in your mind, like there is some sort of normal force like pushing the table downward and the table pushes the book upward. Action and reaction pair, there are two different pairs, I have already told you. And the next thing, we will move towards your next question, what it is. Write down the question. Why don't action reaction forces cancel out each other's effect? Because you just have to write down the question for that situation. If action and reaction forces are equal and opposite, why don't they cancel each other's out and stop all the motion at the spot over there? If action and reaction forces are equal and opposite, so why don't they cancel each other? And why don't they stop all the motion at the point after cancelling? So what you just have to think, if I push you right, push you towards your right side with 10 Newton and you push me on the left with 10 Newton, I'm just giving you some sort of forces. 10 Newton is the unit for force. So do we cancel out, or do we each feel the force separately? What do you think? If you are pushing me on my right and I'm pushing you on your left, so what's happened over there? This is the most common misconception about Newton's third law as well. Fine. Like action and reaction forces do not cancel out because they act on different objects, not on the same object. Got it? When the forces are acting on the same object, you can say that they can cancel out each other's effect. Fine. So if I'm just going to explain this thing, if action and reaction are equal and opposite, fine. If action and reaction forces are equal and opposite, so shouldn't everything cancel or nothing ever move from that? So the answer is obviously no. And here is why I'm just going to explain it right now. The action force acts on object B. Action force is acting on the object B, and the reaction force acts on object A. When there are two different objects, That is why action and reaction are not cancelling each other's effect. While when the action, in that case, like the object is single, and when you are applying different forces on the opposite direction and equal with equal magnitude, that is how they can cancel each other's effect. But when they are on the different objects, forces can only cancel when they act on the same object. Fine. When they are on a different object, they are not going to cancel each other's effect. Like I'm just giving you the example. I push you right with 10 Newton and you push me on the left with 10 Newton. No, we are affecting each other, not cancelling each other's out. So you can feel 10 Newton force over there, and I can also feel 10 Newton of force. But each force act on different person. Like 10 Newton force is exerting on me and 10 Newton force is exerting on you. That is why motion is still possible. Got it? So, according to the question demand, what you just have to write. This is the most common misconception about Newton's third law. Action and reaction forces do not cancel out, but sorry, because they act on different objects. The action force acts on object B and reaction force acts on object A. That is why they are not going to cancel each other's effect. Is this thing clear? I'm just going to give you another example. Like earth pulls you down and you pulls earth as well as a reaction force up towards you. So these forces act on different objects. So they cannot cancel each other's effect. There is some sort of movement over there. Maybe it is in a very minimum amount. So it's very difficult for us to even notice. Got it? So we are just moving towards the next question. You can also see the walking action and reaction pair on your books as well. So, which type of question can be made from that? How do action and reaction forces allow you to walk forward even though you push backwards on the ground? So, how do action and reaction forces allow you walk forward up? How you people are able to move in the forward direction even though you push the ground backward with the help of your feet? So you just have to think now, which direction do your feet push on the ground when you take a step forward? When you are taking a step forward, so your feet are pushing the ground in which direction? Obviously, it backward direction. Very well done. So in backward direction, your feet are pushing the ground, and as a result, your the ground exerts a reaction force, and you people are able to move in the forward direction. Got it? So, what do you have to write for its answer? When you step forward, when you step forward, your foot pushes backwards on the ground, that is the action force. And by the Newton's third law of motion, the ground pushes forward on your foot with an equal force, that is a reaction force. And this forward reaction force from the ground propels you forward as well, and the earth has a very greater mass as compared to you. So while you are moving forward, noticeably, you can notice yourself, you are moving forward, the earth moves to a very minimum amount, a very tiny amount backward. So without the reaction force from the ground, you couldn't even walk. Got it? And you also you people are also able to have a look on your next page, second page of 10.2. The person who is walking, like foot pushing the ground, so it is the action. This is the action force, and you will have to draw the arrow in towards the ground. Next is that foot pushes back on the ground. Now the foot pushes back on the ground, and for the reaction, the ground pushes the foot. So it is a reaction force, that is ground pushes foot forward, and as a result a person is able to move. Got it? So moving towards your next question, bete, it must be about the swimming, action and reaction in water. So you must have to write down the question for that. How does a swimmer use action and reaction forces to move forward through water? How does a swimmer use action and reaction forces to move forward through water? So you just have to think now, when a swimmer's arms push water backwards, what happens to the swimmer? at that point when he is pushing the water backward. So, what do you think that what's happening over there? Okay. So, swimming is the Newton's third law of motion in action. How it is. When a swimmer sweeps their arms backward through the water, that is the action force. Got it? When the swimmer sweeps their arm backward through the water, this is the action force, beta. That is pushing water backward. This is the action which is done by the swimmer. And water immediately responds with an equal and opposite reaction force, pushing the swimmer forward. And the more powerful the arm stroke, the bigger the action force is over there. जितना आप जोर से पानी को पीछे की तरफ धकेलेंगे, जितना बिगर एक्शन फोर्स होगा, therefore the bigger reaction force is over there which is just over there to push the swimmer forward. जितना आप बैकवर्ड डायरेक्शन में ज़्यादा फोर्सफुली फोर्स अप्लाई करेंगे, उतना ही स्विमर जो है वो फॉरवर्ड डायरेक्शन में मूव करेगा. So the forward strokes means like more forces in both directions. Faster strokes means both forces, and in both directions there are more forces. And this is also why swimming in a more streamlined position is faster. Why? The swimmer just have to get the streamlined position even to reduce the water resistance which is over there. Got it? So it reduces the water resistance while maintaining the forward reaction force. So this is how that's all. You just have to be in your mind. And what will be the key answers or the key points for that question? A swimmer's arm pushed backward on water, that is the action force. And what will be the reaction force? You must have to write it in your mind, keep this thing in your mind, and must have to written. The water pushes the swimmer forward with an equal and opposite force as well. So similarly, the swimmer's legs kick downward and backward. By kicking downward, the water responds in upward direction, and for moving backward, for pushing the water backward, the water will react in the forward direction. So the swimmer's leg kick downward and backward, that these two things are the actions, and the water pushes upward and forward, it is a reaction. Is it clear? Now we are just moving towards our next question from the same topic. Here you can rockets and jet engines over there. Rockets and jet engines with it. So the question can be, explain how a rocket moves forward by pushing hot gases backward. How a rocket moves forward by pushing hot gases backward. So there is also a action and reaction pair forces of there. Like if you are standing on the skateboard, I'm just going to give you some clue that you must have to do your brainstorming and thinking capability. If you're standing on a skateboard and you throw a heavy ball forward, what happens to you? अगर आपने बॉल को आगे की तरफ फेंका है तो आपके साथ क्या होगा? आप स्केट बोर्ड पे हो तो आप पीछे की तरफ थोड़ा ड्रैग हो जाओगे. एम आई राइट? सो व्हाट डज इट मीन? ये आपको किस साइड पे लेके जा रहा है? इसकी जो अभी मैंने आपको एग्जांपल दी है, यू जस्ट हैव टू थिंक अबाउट इट. Like rockets, we are talking about the rockets. So rocket, it is a very good example of Newton's third law of motion, you can say. The rocket engine burns enormous amount of fuel, and the products which are as a result of this burning of fuel, the product which are hot gases, and they are blasted out from the back of the rocket, and at a very greater speed, you can say at a thousands of meters per second. The speed will be thousands of meters per second with a very greater speed. That is the action force. So as a result, the equal and opposite reaction must be over there. So the gases push the rocket forward or upward in a launch. Got it? Here is like what's truly amazing. The works in this works in the space, and a complete vacuum is over there with no air at all. So jet engine just pushes against air, but rockets carry their own oxygen. They push their own gases backward, and the gases which are just exhausted from their engines, these gases uh, get the rocket able to move forward direction. Got it? So what you must have to write for its answer. A rocket engine burns fuel and expels hot gases out of the back at very high speed. And this expulsion of gases in the backward direction is the action forces. So, by Newton's third law of motion, the gases push back on the rocket forward. The gases push back on the rocket forward, and this is the reaction force, or you can also say it is a thrust. The greater the force, that is action force by means of expelling the gases, the greater the forward thrust. So this works in the vacuum as well, where there is no air. So it's based on the jet engine works reaction forces, not on the pushing against the air. Got it? There is not any pushing against the air, or the air resistance is over there. It's all about the action and reaction, and which type of action. The action which is done by the gases which are exhausted as a burning of fuel in the rocket. So moving towards your next question, the water rocket experiment. It is also given on your books on the second page of 10.2 beta. So the question can be made from that. In a water rocket experiment, why does pumping more air into the bottle cause the rocket to fly higher? In a water rocket experiment, why does pumping more air into the bottle cause the rocket to fly higher? Now, I have just told you, जब हमने ये किया था, so what was that? A water rocket is a plastic bottle that was filled one third with water. It was filled with one third of the water. Are you getting my? Excuse me. Yes. So, sorry. A water rocket is a plastic bottle that was filled with one third with water, and two part of that, these are pumped with the air, which is exerting pressure inside it. So when released, the compressed air forces the water out downward. The compressed air which was present inside that water bottle rocket, they uh, the air forces the water out downward. This is the action force which is acting in the downward direction. So what will be the reaction force, and in which direction it must have to be applied? In upward direction. So the reaction force which is always acting in the upward direction on the rocket, it is pushing it upward. Got it? So moving next, this is all about its action and reaction, and you can also draw the arrows which are in contact with that over there. uh, I think that's enough for its explanation. Or do you have any query concerning to this rocket air bottle? Because I'm thinking that we must move towards the next question. If there is any confusion, you can ask the question in your chat. Otherwise, we are just moving towards the next question. Is it clear, class? Okay, no queries. Fine. So moving towards the next question, that is about balloon jet. Okay, Masab, you are not getting the point, and the one more student. Okay, fine. I'm just going to repeat that previous question where we have just discussed about the water rocket bottle. Got it? So the water rocket experiment is one of the most demonstrations of Newton's third law. And uh, what you people have to do, you just have to fill a bottle that is one third with water. What does it mean? If the bottle is, if the space of that or the capacity or the volume of that total whole bottle is divided into three different parts. So out of these three, only one contains the water, and remaining two is filled with air. So air is also very compressed. Compressed air has a very greater pressure as compared to the normal air. So you must have to fill a bottle one third with water and pump in the compressed air over there. And then when you just have to open that lid or the cap of that bottle, you can easily have a look on your books as well. So what does happen over there? So air pressure forces the water out downward, in downward direction, and it is very powerful action force. So as a result, the equal reaction force will also be exerted, which helps the you can say the rocket shoots upward. And this is how the more air, the more pressure, the more air in the compressed form inside the bottle, it is over there, and it helps to shoot the rocket more forcefully in upward direction. Is it clear? Moving towards your next question, Bete. We were talking about the balloon jet, that is, action and reaction forces are also there. So, question can be made from that part. It is when a blown up balloon is released without tying it. When a blown up balloon is released without tying it, it flies across the room. Explain the using action and reaction forces. What is the question is over there? They want to ask that when you are just blowing a balloon, आप अगर कोई एक balloon है उसमें आपने हवा भरी है, आपने इसको properly tie नहीं किया बल्कि आपने इसको छोड़ दिया है, तो what's happening over there? It just flies across the room, and after some time it just move towards the ground or the floor. So you just have to think, what you just have to think, which direction does the air come out of the balloon? There, when you just release that balloon, in which direction the air comes out of that balloon, and which direction does the balloon move as a result, in which direction balloon does have to move? So think that both of these forces or both of these directions are same or opposite. You just have to do your own brainstorming by having a look on these points that I have just told you. So the balloon jet is probably the simplest demonstration of rocket propulsion. Say at your home, you can easily judge that how the rocket is doing its work or how it's working over there. Got it? So blow up a balloon, let it go without tying. So the elastic balloon squeezes the air out from the opening backward, and that is the action force. And this is the action force in which air is moving backward. And what will be the reaction? The reaction force is obviously it is equal and opposite, it is in the opposite direction, and the balloon moves in the forward direction. It's exactly the same physics like I have already told you in the previous question where the rocket and the jet engines do. So what they are doing, they are not using any air resistant or the air which is present around that particle. They are using their own exhausted fumes, gases, which are produced as a product of burning that fuel. Similarly, the balloon is also using its own air, which you have just blown inside that. So, and the only difference is that the source of expelled material, air in a balloon and hot gases in the rocket. While otherwise, you can say that both phenomena is exactly the same. Got it? And so, what you people will have to write for its answer: the balloon contains compressed air under pressure. The balloon contains compressed air under pressure. When released, the elastic sides of the balloon squeezes the air out. They squeezes the air out. When they squeezes, they push the air outside through the opening which is present on the backward. This is the action force. And by the Newton's third law of motion, the air pushes back on the balloon in the opposite direction as well. So as a result, the balloon is moving in the forward direction. This is a reaction force. Got it? The balloon moves forward or upward. You can say if you are aiming it towards, so it will move upward. If you are aiming towards your right side or left side, so it will move towards according to that direction which are you just going to give them. Okay, so moving towards your next question, Bete. This is the tug of war, that is the force pairs are over there. You can easily have a look on the spring balances which are given over there. So the question can be made, in a tug of war using two spring balances, why do both spring balances show the same reading? There is some sort of misprinting, and I have already explained you during my lecture that why is the what kind of misprinting is over there, and what is the exact actual reading which is given on the spring balance that is equal to each other. So what you just have to think for its answer. If I pull a rope with 30 Newton and you hold the other hand, and how much force does the rope exert on you? अगर मैं पुल कर रही हूँ तो आपके ऊपर कितनी एग्जर्ट हो रही है फोर्स? अगर मैंने खींचा ही है, इफ़ आई एम जस्ट गोइंग टू पुल दैट रोप विथ 30 न्यूटन, तो दूसरा कोना आपने पकड़ा हुआ है, अगर आप कुछ भी नहीं कर रहे हैं तो फिर भी आपके ऊपर कितने कितने न्यूटन फोर्स जो है वो एग्जर्ट हो रही होगी? ऑब्वियसली इट मस्ट बी हाउ मच फोर्स. इफ आई एम अप्लाइंग 30 न्यूटन फोर्स, देन वट डू यू थिंक आप पे कितनी होगी? एनी वन ऑफ यू कैन गिव मी द आंसर इन योर कमेंट्स बॉक्स. इफ अप्लाइंग फोर्स इज 30 न्यूटन, तो आप उसमें से कितने न्यूटन आपको फील हो रही है? हाउ मच फोर्स इज फीलिंग टू यू? इट्स ऑब्वियसली 30 न्यूटन. सेम, गुड. The next thing is that um, it's about your like if two people are holding a tug of war using two different spring balances connected together, no matter how hard they pull, both spring balances always show the same exact reading. Why? Because when person A pulls with 30 Newton, the reaction force, that is person's B pull, is also 30 Newton by the Newton's third law, action and reaction. So equal and opposite direction, and the spring balances measure these equal forces and display identical readings on the spring balance on. And sorry, what I was just thinking. Yes, it's 30 Newton, bete. Anyone there is just writing the answer. If you are like, I was just talking about when any person, like if you are pulling that spring balance with 30 Newton, so the reaction force, if the other side, on the other hand, let's suppose I am over there, so there is also a pulling force that is exerted by me as well. And according to the Newton's third law of motion, it must be the equal and in opposite direction. So the spring balance measures these forces are very equal, and the readings must be the identical to each other. Same reading वो show करेंगे. इफ यू पुल हार्डर, अगर आपने लाइक बहुत ज़ोर से आपने उसको खींचा है, तो रीडिंग गोज अप फॉर बोथ बैलेंसेस साइमल्टेनियसली. एक ने उतनी फोर्स लगाई हुई, लेकिन आपने उसको ज़ोर से खींचा है. जब आप उसको खींच रहे हो तो ऑपोजिट डायरेक्शन में भी उतनी फोर्स वो ज़्यादा अप्लाई करना स्टार्ट हो गया. दैट इज़ वाई the both spring balances show the same reading. So what you just have to write for its exact answer. In the tug of war experiment, person A and person B each hold one end of two connected spring balances. Two persons are holding the two different spring balances ends. So when A pulls on B's spring balance with force F, let's suppose, हमने उसको कोई भी नाम दे दिए. आपने क्या किया? व्हेन ए पुल्स ऑन बीज स्प्रिंग बैलेंस को आप पुल कर रहे हो, तो आपने कोई अप्लाई की फोर्स दैट इज, लेट्स सपोज इट इज 5 न्यूटन, एंड बीज स्प्रिंग बैलेंस exerts an equal and opposite force back on A without applying any force by its person who is holding it. Since the forces are equal in an action and reaction pair, so both spring balances read the same reading. And this is true regardless of how hard either person pulls. The force in the connected system is transmitted equally, and this is a direct measurable demonstration of Newton's third law of motion. Got it? So you can draw the arrows like if person A pulls 15 Newton, fine. So person B also, the reading on the second spring balance also will be remain the same. Okay, the question that is asked by Musab, that either one person applies less force and the one is applying the harder or the greater force. So if the one person is applying the harder force, that is what I am just going to, I was just asking, talking about that thing. अगर आप ज़्यादा ज़ोर से उसको पुल कर रहे हैं, ठीक है, इफ़ यू आर पुलिंग दैट द स्प्रिंग बैलेंस विद सर्टन फोर्स, तो जो सेकेंड पर्सन होगा, ठीक है, उसके ऊपर वो उतनी ही रीडिंग शो करेगा जितनी आपने खींची है. इट डजेंट मैटर कि दूसरे वाला कम, अगर दूसरे वाला कुछ भी नहीं खींच रहा, कोई पुलिंग फोर्स नहीं अप्लाई कर रहा है, उसके बावजूद भी सेम रीडिंग शो होगी, क्योंकि जो दरमियान में स्प्रिंग है वो ऑटोमेटिकली एक्शन और रिएक्शन की वजह से पुलिंग और दोनों साइड पे डिफरेंट डायरेक्शन में एक्सर्ट करने लग जाएगा फोर्सेस को. इज इट क्लियर? मूविंग टुवर्ड्स योर नेक्स्ट क्वेश्चन बच्चे. It's the effect of mass on action and reaction pair, and the question can be, in an action reaction pair the forces are equal. Why does the smaller object accelerate much more than the larger one? अच्छा, ये बहुत ही मज़े का क्वेश्चन है. इसमें आप देख सकते हो, आपसे क्या कह रहे हैं, इन एन एक्शन रिएक्शन पेयर फोर्सेज आर इक्वल. फोर्सेज आर इक्वल. और why then does the smaller object accelerates much more than the larger one? You are just having the example, if a truck and a bicycle collide with each other, you just have to think for that question. If a truck and a bicycle, एक ट्रक है और एक साइकिल है, दे कोलाइड, सो दे पुश ईच अदर विद इक्वल फोर्सेस. सो किसको ज़्यादा फर्क पड़ेगा, ट्रक को या बाइसिकल को? सो व्हाट डज द बाइसिकल फ्लाई बैकवर्ड मच फर्दर देन द ट्रक मूव्स. ऐसा क्या हुआ था कि आपकी बाइसिकल बहुत ज़्यादा दूर गिर गई, हालांकि बाइसिकल भी उतनी ही ज़ोर से टकराई थी जितने ज़ोर से आपके साथ ट्रक टकराया था. अब डिपेंड करता है उसका मैग्नीट्यूड भी फोर्स का. एम आई ऑडिबल टू यू क्लास? Not because of weight. I don't know who is that person with. It's about its mass. इट्स अबाउट इट्स मैथ. अगर उसका मैथ ज़्यादा होगा तो ऑब्वियस है कि वो ज़्यादा फोर्स एक्सर्ट करेगा, और जिसका मैथ कम होगा उसके ऊपर वो ज़्यादा अप्लाई होगी, वो उसको फील ज़्यादा करेगा. हाउएवर द इफेक्ट ऑफ दैट फोर्स डिपेंड्स ऑन द मैथ ऑफ दैट ऑब्जेक्ट. एंड न्यूटन्स सेकंड लॉ, जो कि चलें आप लोगों का है नहीं, बट मैं हल्का सा यहाँ पे आपको क्लू दे देती हूँ. व्हाट इज़ दैट जितना मैथ्स को आप उसके एक्सेलरेशन से, उसकी मूविंग स्पीड के साथ मल्टीप्लाई करते हो तो आपके पास फोर्स आ जाता है. इफ़ नो, यू जस्ट हैव टू टेक एन एग्जाम्पल अगेन, कार एंड सॉरी ट्रक एंड बाइसिकल वाली अपने माइंड में लेकर आएँ. उसमें देखिए क्या हो रहा है कि मैथ्स कितना है, जितना ज़्यादा दोनों की स्पीड एक जितनी थी, लेट सपोज दोनों एक जितनी स्पीड से ऑपोजिट डायरेक्शन में मूव करते हुए आ रहे थे, बट जिसका मैथ ज़्यादा होगा, बाय मल्टीप्लाइंग द मैथ विद इट्स एक्सेलरेशन और द मूविंग स्पीड, यू कैन से उसका फोर्स उतना ही ज़्यादा हो जाएगा. सो द सेम फोर्सेज बट डिफरेंट मैसेज मीन डिफरेंट एक्सेलरेशन, और वो ज़्यादा स्पीड आपको फील होगी. गॉट इट? अगर आपके पास स्मॉलर मैस आ रहा है, उतनी ही फोर्स है, तो आपके पास इतना ज़्यादा एक्सेलरेशन नहीं होगा, स्मॉल ऑब्जेक्ट्स मूव्स अलॉट. लेकिन अगर आपका लार्जर मैस है और उतनी फोर्स आपके ऊपर लग रही है, तो आपका ऑब्जेक्ट बहुत ज़्यादा मूव नहीं करेगा, जैसे कि बाइसिकल और ट्रक की एग्जाम्पल मैंने अभी आपको समझाया. गॉट इट? सो मूविंग टुवर्ड्स योर नेक्स्ट क्वेश्चन बेटा. हाउ, हु इज विद गेमिंग जोन नेम? व्हाट्स योर नेम बेटे? हु आर यू? महद दैट वाज क्वाइट इजी. मैंने आपसे कहा है कि जितनी ज़्यादा आपकी मैस होगी, ठीक है, और वो अगर थोड़ी है आपके पास, ट्रक की मैस ज़्यादा होती है, तो ऑब्वियसली उसको वो ज़्यादा ज़ोर से हिट करेगा, क्योंकि वो मल्टीप्लाई हो रहा है आपके एक्सेलरेशन के साथ, तो वो उसकी फोर्स ज़्यादा हो जाएगी. अगर आपके पास छोटी स्मॉलर मैस वाला ऑब्जेक्ट होगा तो वो कम फोर्स अप्लाई करेगा. मूविंग टुवर्ड्स द नेक्स्ट क्वेश्चन, अ स्काई डाइवर एंड द अर्थ. सही. So we are just going to talk about gravity pair. The question can be made from that diagram. As a skydiver falls, the earth attracts them downward. What is the reaction force and on which object does it act? So what you just have to think for that question. We already have learned that gravity pulls all things towards the earth. So gravity pulls that skydiver towards the earth as well. But does the skydiver also pull the earth towards themselves? upward in upward direction. So action forces and रिएक्शन फोर्सेस. अभी पीछे मैंने आपको क्या बताया कि अगर मैस ज़्यादा होगा तो आप फोर्स को फील नहीं कर सकते हैं, अगर मैस कम होगा तो आप उस फोर्स को फील कर सकते हैं. इन केस ऑफ दैट स्काई डाइवर, द mass of skydiver as compared to the earth's mass, it is very less, so the pulling force of that earth can be felt by that skydiver. और आप उसको देखते हैं कि वो डाउनवर्ड मूव करता हुआ आएगा. ठीक है, अभी देखें इसको. आपको आंसर के लिए क्या चीज़ें आप इसमें मेंशन कर सकते हैं बेटे. द एक्शन फोर्स, दैट इज योर अर्थ्स ग्रेविटी. व्हाट यू हैव टू राइट डाउन, अर्थ्स ग्रेविटी पुल्स द स्काई डाइवर डाउनवर्ड. And what will be the reaction force? The reaction is the skydiver's gravity, which pulls the earth upward, which is an equal and opposite force. This is a gravitational action and pair, action and reaction pair, you can say. And the reaction force acts on the earth. The reaction force is acting on the earth, not on the skydiver. On the skydiver, which force is acting? The action, which is done by the earth. Is it clear? So the skydiver with much less mass और स्मॉलर मैस, आप उसको क्या करेंगे कि वो उसको फील करेगा और डाउनवर्ड मूव करता हुआ आ जाएगा. मूविंग टुवर्ड्स द नेक्स्ट क्वेश्चन. हिटिंग अ वॉल. व्हेन अ बॉल मूविंग ईस्टवर्ड्स hits a wall with 10 Newton of force, and what is the reaction force and what does it cause? When a ball moving eastwards hits a wall, तो अब क्या होगा, उसकी डायरेक्शन चेंज हो जाएगी. ईस्टवर्ड से वो किधर हो जाएगी, वेस्टवर्ड हो जाएगी. हिट अ वॉल विद अ 10 न्यूटन ऑफ फोर्स, तो फोर्स विल रिमेन द सेम. व्हाट इज द रिएक्शन फोर्स एंड व्हाट डज इट कॉज? द बॉल पुशेज द वॉल ईस्टवर्ड, so as a result the wall pushes it back in westward direction. Action force किधर हो रही थी बेटे, the ball pushes the wall eastward with 10 Newton, and what will be its reaction force? The wall pushes the ball westwards in backward direction with 10 Newton. Same, equal and in opposite direction. Got it? So the reaction force from the wall changes the ball's direction and it bounces back westwards. The reaction force may also compress the ball, which changes its shapes, and ball slows down, stops briefly, and then accelerates back towards westward in the backward direction. So moving towards next question, that is very relevant, so I'm not engaging you a lot for these questions now, because already we have just done action and reaction pair in detail, that how they are working. Next question is about the fire extinguisher. Fine. Why do you need to brace yourself when starting a fire extinguisher? Explain using Newton's third law of motion as well. So the fire extinguisher क्या करता है? It has some sort of foam inside it, and it shoots its foam forward in the forward direction. And what forces does that create on the person holding it? कौन सी डायरेक्शन में आएगी? बैकवर्ड डायरेक्शन में आएगी. ठीक है, अगर फायर एक्सटिंग्विशर में से जो फोम निकल रहा है वो फॉरवर्ड डायरेक्शन में, वो किधर जा रहा है? फॉरवर्ड जा रहा है, तो वो एज अ रिजल्ट फायर एक्सटिंग्विशर के ऊपर ही किधर फोर्स अप्लाई करेगा? इन द बैकवर्ड डायरेक्शन. गॉट इट? सो द फायर एक्सटिंग्विशर रिलीजेस अ फास्ट jet of foam, or the gases you can say, forward with a very great force, and this release of foam, you can say, in the forward direction is the action force. So what will be the reaction? The reaction force is that the fire extinguisher also experiences a reaction force in backward direction, and this reaction force or the recoiling force pushing the person backward. If you don't brace yourself, कदम जमा के अगर आप खड़े नहीं होंगे मजबूती से, तो आप क्या करेंगे? यू विल हैव द चांसेस टू फेल बैक. ओके जी, मूविंग टूवर्ड्स योर next question, that is jumping. When you are going to have a jump, आपने जब जंप करना होता है तो आप क्या करते हैं? You are pushing the earth in downward direction. When you are this is the action, and as a reaction अर्थ क्या करेगी? आपको पुश कर देगी अपवर्ड में. बहुत ईजी है. सो क्वेश्चन इज एक्सप्लेन वाई यू मस्ट पुश डाउनवर्ड ऑन द अर्थ टू जंप अपवर्ड इनटू द एयर. क्या होगा जब एक्शन लगाएंगे? तो एज अ रिएक्शन अर्थ आपको ऊपर की तरफ पुश करेगी. टू जंप अपवर्ड, योर लेग्स पुश डाउनवर्ड ऑन द अर्थ, and this is the action force. And by Newton's third law of motion, the earth pushes backward. The earth pushes back you in the upward direction with an equal and opposite force. This is the reaction, action and reaction pair हो रहा है. यहाँ पर आपने बेटे वही बताना दोबारा से. Next is the boy pushing against a wall. You can also see the picture on your book as well. When a boy pushes against a wall, the wall pushes back equally. Why does not boy go backward? आप अगर पीछे धकेल रहे हो तो आप गिरते नहीं हैं, और ना ही जो आपको वॉल पुश कर रही है इन द ऑपोजिट डायरेक्शन, और ना ही आप मुंह के बल गिरते हो. सो व्हाट इज द साइंस बिहाइंड इट? बिकॉज बोथ फोर्सेज आर equal with each other. So what you must have to write, bete, action and reaction pair again. When the boy pushes the wall forward, the wall pushes the boy backward as a reaction, and however the boy also has a friction between his feet and the floor, and this friction acts forward on the boy, which is the opposing force. So the reaction force from the wall, boy remains the stationary. And if the boy pushes harder, the reaction increases and friction increases to match. The boy doesn't go backward because the net force on him is now zero. क्या है? आप जो कदम जमा के खड़े हुए हैं तो आप क्या क्रिएट कर रहे हैं? फ्रिक्शन क्रिएट कर रहे हैं. नाउ आपने पुश किया था वॉल को इन बैकवर्ड डायरेक्शन, एंड वॉल एज अ रिएक्शन पुशिंग यू इन फॉरवर्ड डायरेक्शन. नाउ बोथ दीज force and action and reaction are in equal in magnitude. That is why you people are able to be in the stationary position and are not moving. Next question we are just moving towards. It is for each situation identify the action and reaction forces. ये तो आप कर लेंगे. फिश स्विमिंग एंड अ गन फायरिंग अ बुलेट. फिश स्विमिंग में आप मुझे बताएं व्हाट विल बी द एक्शन फोर्स. द फिश फिन पुश वाटर बैकवर्ड लाइक अ स्विमर. विच एक्शन क्या करता है स्विमर? इट पुशेस द वाटर बैकवर्ड, एंड एज अ रिएक्शन क्या होता है कि वो आगे की तरफ वाटर जो है पुशेस दैट स्विमर इन द फॉरवर्ड डायरेक्शन. गॉट इट. एंड नेक्स्ट इज गन फायरिंग अ बुलेट. उसमें क्या हो रहा है एक्शन के एक्सपैंडिंग गैसेस पुशेस द बुलेट फॉरवर्ड आउट ऑफ दैट बैरल, एंड एज अ रिएक्शन क्या होगा? बुलेट जो है या जो गैसेस थी दैट पुश बैक ऑन द गन इन बैकवर्ड डायरेक्शन. दैट इज वाई गन किक्स यू बैक व्हेन यू फायर्ड एंड रिकॉइल फ्रॉम द it is according to your Newton's third law that action and reaction are equal but in opposite direction. Got it? Next is, if the forces are applying on different bodies, why it is important that action and reaction forces act on different bodies, not on the same. डिफरेंट बॉडी पे होती है तो तभी वो एक दूसरे को वो कर रही हैं. अगर एक ही पे होती तो क्या कर देती? कैंसल ईच अदर्स इफेक्ट, तो उसका कोई फर्क ना रहता. ठीक है. लाइक इफ यू आर हैविंग अ सिंगल टग ऑफ वॉर, एक रस्सा है और उसको दोनों साइड से ऑपोजिट डायरेक्शन में आप दोनों अप्लाई किधर फोर्स कर रहे हैं? उस टग ऑफ वॉर पे, उस वॉर के ऊपर कर रहे हैं ड्यूरिंग दैट टग ऑफ वॉर. तो जब आप उसके ऊपर रोप पे अप्लाई कर रहे हो फोर्स इन ऑपोजिट डायरेक्शन, तो इट कैन कैंसल ईच अदर्स इफेक्ट, एंड एज अ रिजल्ट यू आर इन द स्टेट ऑफ रेस्ट. फाइन. सो क्वेश्चन जो मैंने भी आपको बताया, व्हाई इट इज़ इंपॉर्टेंट दैट एक्शन एंड रिएक्शन फोर्सेज एक्ट ऑन डिफरेंट बॉडीज. क्यों होना चाहिए? इफ एक्शन एंड रिएक्शन फोर्सेज एक्टिंग ऑन द सेम बॉडी, दे कुड कैंसल ईच अदर्स इफेक्ट एंड नथिंग वुड एवर चेंज इट्स मोशन. कोई किसी किस्म की मूवमेंट नहीं होगी, कुछ भी नहीं हो रहा होगा. ईच ऑब्जेक्ट एक्सपीरियंसेस ओनली वन ऑफ द पेयर ऑफ दोज फोर्सेज, एंड ईच ऑब्जेक्ट रिस्पॉन्ड्स इंडिपेंडेंटली बेस्ड ऑन इट्स ओन. गॉट इट. इन द केस ऑफ एक्शन एंड रिएक्शन, जब दो डिफरेंट ऑब्जेक्ट्स आ रहे हैं तो वो दोनों डिफरेंट ऑब्जेक्ट्स एक्सपीरियंस करते हैं डिफरेंट टाइप की फोर्सेस को. इज इट क्लियर? इज देयर एनी कंफ्यूजन क्लास? And I think what's time now, bete? It's almost 1 hour. Now we are just moving towards our next topic, that is what it is. It's 10 point. 10.3. What do you think that we have to 10.3, or how much time is left? Am I audible, class? It is just reconnecting and I don't know what's going wrong.